After finding a suitable data set, the next step is to figure out the right statistical method to answer your research question. Since most econometrics projects are based on observational data, which is limited in time and scope, frequently we have omitted variables in our dataset. This gives rise to confounding effects among variables in our datasets. We think X might have caused Y based on the data we have collected, but in fact, a variable Z that is not included in our dataset might have determined both X and Y. Imagine a scenario where you're standing in an open field near a forest and watching a group of Canadian geese flying across the sky. All of a sudden, you heard a loud sound, and a goose fell from the sky. Soon after, you heard another loud sound, and another goose fell from the sky. Hence, you concluded that the loud sound caused the geese to fall, because that is the correlation that you are able to observe. In reality, though, the geese fell because a hunter standing on the other end of the forest was actively shooting at the geese. You couldn't observe the hunter, hence he was standing far away from you, so you made the erroneous conclusion that the geese fell because of the loud sound. For our analysis, we have to remember that correlation is not the same as causation, and we have to try our best to root out any confounding effects from our analysis, so we don't conclude on the wrong causal effects. Here is an example of US highway fatality rate and fresh lemon imports from Mexico. Based on this graph, you see that the number of lemons imported from Mexico is negatively correlated with total US highway fatality rate. Can we hence conclude that we should import more lemons from Mexico so we have a lower highway fatality rate? No, we cannot, because this relationship doesn't make sense. There is no story we can tell behind this relationship that justifies a causal effect. There has to be other variables that are driving both of these variables that we don't observe in our data set that are confounding the effects. In your analysis, you have to be very careful about this. Just because two variables have very strong correlation, it doesn't imply causation between them. Here's another example of confounding effects between variables. In this graph, we see that the number of Nobel laureates are, as a percentage of population, is positively correlated with chocolate consumption in that country. Does consuming more chocolate help the countries generate more Nobel Prizes? Obviously not. It could be that the population in richer countries consume more chocolate, and richer countries also have more resources and better research facilities, and hence you observe a higher number of Nobel laureates in those countries.